We want to use the formula for acceleration to calculate acceleration, change in velocity, or time. So we know for acceleration that that's the change in velocity over time. So that's going to be v final minus v initial over total time. So what you want to do when you do these problems is identify what you have first, because notice I have 1, 2, 3, 4 variables. So if it's going from 10 to 100 meters per second, this is my v initial, this is my v final, over a period of 5 seconds, then acceleration equals v final, which is 100 meters per second, minus v initial, minus 10 meters per second, over 5 seconds. So that becomes 90 over 5, which is 90 over 5, which is 18 meters per second squared. All right, so if the car is traveling at 20 meters per second, so it's already doing this, so this would be considered the initial velocity. It accelerates at 2 meters per second squared, so this is acceleration, and it does that for 5 seconds, that's t. It wants to know the final velocity, okay? So we have acceleration equals the change in velocity over time. What I'm going to do is I'm going to multiply by time. So it turns out that acceleration times time equals the change in velocity, okay? Well, that means the change in velocity equals acceleration is 2 meters per second squared, time is 5 seconds, so my change in velocity is going to be 10 meters per second. But it wants the final velocity. So if it wants the final velocity, what I need to do is I know that the final velocity minus the initial velocity is 10, but the initial velocity is 20. So v final minus 20 equals 10. By adding 20 to both sides, I get that the final velocity is 30 meters per second. Now we want to calculate the acceleration using a velocity time graph. Now you need to be careful. This is not a position time graph. This is a velocity time graph. So this is talking about the speed over a certain time. Well, that's really important because from a graph, from a velocity time graph, I can get the acceleration from the slope of a velocity time graph. So it wants us to calculate the acceleration from A to B, so it's really asking us to find the slope here. So I need to find the rise over the run. So my rise here over the run is going to be acceleration. Well, I'm going up 5, 10, 15, 20. So that's 20 meters per second divided by the run. And if I follow that along, this is going to be 2 seconds. So divided by 2 seconds, and that's going to give me 10 meters per second squared. If we went from B to C, if you'll notice, right, I'm not rising up or rising down. If you're looking at the change in velocities, you'll notice that I'm starting at 20 and ending at 20. So if I'm using v final minus v initial over time, I'm going to get 20 minus 20 over some amount of time, which is like 2 seconds, but that's just 0 meters per second squared. Okay, so on a velocity time graph, if the slope is 0, which for a horizontal line is 0, then the acceleration has to be 0. And then from E to F, okay, so I'm going across 2 seconds. So my run is 2 seconds, but notice I'm falling here. I'm not going up, I'm actually going down. How much? 5, 10, 15, 20. So I'm going down 20 meters per second. So I have for the acceleration is the fall over the run, which equals negative 20 meters per second. over 2 seconds, which is negative 10 meters per second squared. And again, you can use the final velocity minus the initial velocity, and you can even use the change in time. So this is really just like the slope formula. So my final velocity was 20. My initial velocity is 40 over my final time was 10 seconds minus my initial time was 8 seconds, and you get negative 20 over 2, and then you're still getting this negative 10 meters per second squared. So you can use that slope formula, all right, or the formula for acceleration, change in velocity over change in time. You're going to get the same exact answer.